Well, guess what? The logic changed again. This time around, we're tackling the biggest issue of the previous version. Let's see it in action, and as always, good afternoon. The biggest issue there was actually that I was always placing the nodes on one line. Now we can utilize multiple lines, and let's see how I did that. What you can see right now is the logic with multiline embedded. What will happen in the function getLines of nodes is translating this input into those possibly longest lines. And now that we have this sort of input, you can probably easily see how it's getting translated into the graph. Since the B node is already present in the graph when we are drawing like line by line, then we don't draw it again. We just understand it's there, and the next letter E, should be appended below it as a new line. So what's happening in here is really just building the vector of vectors of strings. You probably can imagine if the mapping is already covered, we just don't repeat it anymore. However, when it was covered but in reverse, we have to actually add it to the next line, when the target is really the first in the line. So if our line was B to C to D, but the next mapping we would have to cover would be A to B, A should really land as the first one in that particular line. The idea later on is to plot those nodes and then add arrows to them. When we have 4 nodes in the line, and the last node is actually connected to the first and the second, this creates the looping of arrows, which we need to take into account, right? We need to move the next line a little bit below so it can fit. And this in turn means that this whole drawing is really very much handcrafted. And we have to take into account not only moving the nodes down, but also moving some of the nodes to the right, which is kind of difficult. When I implemented this logic, there was actually a surprising technical challenge that I didn't really anticipate. We've got this hash map that is a mutable reference. And then we want to grab from it one item and then the second one. And we want to have both of those to be still mutable. So as you can see, the error says, cannot borrow inner 2D mapping as mutable more than once. I don't really borrow a whole inner 2D mapping, that's the whole idea. I want to just grab 2 items from it and edit them separately, which apparently does not go well with Rust. And I kind of get it, because obviously I could grab 2 references to the same item, right? And that could create massive problems. And I figured a way to work with it, so I wanted to share. I grab the inner 2D mapping and actually go to the mutable iterator. In this example, only the values are of interest to me. And then I filter that iterator, including both items. So now here in the current and previous, I potentially have 2 items. The main issue with this situation is I have no idea which item is actually the first one and which is the second one. So what I do next is match on that iterator and actually on using the next function twice. Then depending on what I've got from it, I decide whether one of those is a previous node and the second one is a current node. So as you can see, if both are not present, then I just return none twice. If I have only one of those and the label is the same as the current item, then I know I've got the current item but not the previous one. So I return this. And actually, we could have removed that. We couldn't. No, we can. Sure we can, yeah. Learning on the job, as always. There's also a possibility where we still have one item, but the label didn't match, so that one item has to be the previous one, right? Therefore, and if we have 2 of the items, we have to check which one is the current one and which one is the previous one, so we either return this or the reversed version of that. And this trick works flawlessly, because now I've got two items that I can edit, which is exactly what I wanted. Unfortunately, I'm not very happy with the solution. Yes, it produces very nice output sometimes, but it can be problematic. So first thing that it cannot do for the moment is actually the arrows that are converging back again to one of the items. So if we go with this possibility, check it out. What I've got in here is actually two lines, A to B to C, but also A to D to C. So there should actually be an arrow from D to C in here, but well, it's not there. Yeah, as you can see, working with the arrows pretty much goes down to just if statements, and it's really dependent on a lot of factors, because if we are going from point A to point B, but there's actually something in between, we would have to circumvent that, and there's like many things that you will have to include in this logic, which I didn't do. Another thing that would be really hard to handle would be this situation. We go from A to B to C to D, then from B we create like another branch, which would go to E and F, but then from C we would create another branch, which would go to G. This thing to work would either have to figure out that you have to change places with those two lines, or it will require moving the second line very much to the bottom so the third line can actually fit. Or even the probably best possible scenario would be to go to the very top with that G letter. And every time you actually move one node, well, you have to recreate the arrows, right? Yeah, and this is sort of getting really annoying fast. Guys, I'm also very happy to announce and very happy to celebrate that actually JetBrains Fleet includes now the ability to debug Rust, which is awesome. So let's take a look. If we just go here in debug, yeah, here we go. So this is the output. Yeah, it's a little bit moved, but you get the idea, right? You can actually debug now in JetBrains Fleet. What is kind of surprising to me is that you don't have something like the remove all breakpoints. But I guess it's coming in the next version then. Alright, with the current state of development, let's end the episode in here, and thank you for staying with me till the end. Hit that subscribe and like, and as always, we can do better as a pack. Bye. Hello everybody. Let's time to check out. Really? Alright. So one more time. Alright. Hello everybody. Really? Our source is really the last in the line. We can just add it on top of it. Similarly, that thing would require either to just change places in here. Oh, sorry.